Good morning, sir.
Good morning.
Actually, I saw your homepage on internet, and I read your research activities, research work, and it seems really very interesting to me.
You.
And I'm very curious to know something more about your research activities.
Well, briefly say that in our laboratory, we are interested in the new type of reactions in supercritical conditions, especially supercritical water. Recently, we are now working on making a new type of hybrid nanoparticles by using that kind of conditions. The hybrid materials I mean is organic, inorganic hybrid nanoparticles.
And as you are telling the supercritical condition, what do you mean by supercritical conditions?
Oh, okay. Above the 374 degrees C, 22.1 megapascal, that is really high temperature, high pressure conditions. The water becomes the supercritical state. And under the conditions, we can expect the various interesting phenomena. For the case of the phase behavior, for example, we can expect the homogeneous phase for water, gas, and oil, and the metals of solution. So that it's really the unusual conditions. And one more interesting thing is that another condition, the water molecule itself works as a base or acid catalyst.
Oh, really?
Yeah.
Okay.
So that we can expect various extraordinary reactions using the supercritical water as a reaction medium.
Okay, it means water is not an ordinary thing for us.
Yeah. It's the important is that we can tune the properties of water. We can control the polarity of the water, for example. Sometimes the water's properties becomes just like the polar organic solvent. So that is an important thing. Another important is that water itself is a very green solvent, the most green solvent I think.
Yes, in the sense of pollution.
Yeah, that's right.
Yeah. So as you are telling that hybrid nanoparticle, so what is the hybrid nanoparticles and their applications?
Oh, okay. In fact, we could synthesize by using supercritical condition is that the nanoparticles, which has inorganic inner core, whose size is around the several nanometer, and this particle is chemically bounded with the organic molecules on the surface. So that the important is that if we can change the inner core inorganic nanoparticles, we can make the electroconductive materials, magnetic materials, highly reflective materials, and so on. But another important is that we can control the affinity of our nanoparticles with the organic solvent, aqueous solutions, or the polymer matrix, because we can control the organic molecule to the surface very easily. And once that we can control the affinity of our hybrid nanoparticles with a polymer matrix, for example, we can make the new type of hybrid materials which has the multifunctions. Multifunction, I mean, is the properties of the ceramics and properties of polymers at the same time. That is most important.
Is it also important in biomedical field?
Oh, yeah, exactly. Actually, once that our nanoparticles is covered with the organic molecules, it is very easy to bind these nano-hybrid materials with biomolecules. For example, the antibody of the cancer. Then we can deliver our nanoparticles to the cancer tumor cell. We can easily have a kind of the image of the cancer tumor cells by using our nanoparticles.
Oh, yes. Yeah, it's very interesting.
Yeah.
But for this research, yes, it sounds very good, but what kind of research background is necessary for this, for this research?
That is another important point. Actually, this research is really the new research field. So we need the background of the chemistry, chemical engineering, material science, and physics, and thermodynamics, and so on. So it's really the fusion research field. Actually, in our laboratory, the many researchers who worked in the different fields got together to work together to do this kind of research. So it's really the fusion research field, multidisciplinary research field.
Wow, thank you. It's really very interesting.
If you are interested in making a new research field, please join our laboratory. Thank you.